You ship a support agent. It passes every test. It runs perfectly for weeks. And then, one day, the logic fails in production. The failure starts with a developer tweaking a system prompt to make the agent's tone friendlier, unaware that the small text change has altered how the model interprets its instructions. Normally, the application pipeline checks an order ID first, but after the prompt tweak, the model skips verification and routes directly to issue refund. The model still sounds helpful, so error monitors miss it, resulting in a sudden, massive spike in unverified payouts. This is a silent regression. The agent's polite, conversational text hides the fact that the underlying sequence of tool calls has drifted from the original design. Traditional unit tests are built for predictable, step-by-step code. They cannot validate the dynamic decisions a language model makes when deciding which tool to use. On the other hand, AI evaluation frameworks focus on the output. They check if the prose is accurate or relevant, ignoring the sequence of software functions called along the way. This creates an environment of constant anxiety. A developer knows that adding a single sentence to a prompt could unknowingly sever a critical chain of operations. The industry remains vulnerable because engineers are attempting to secure deterministic operations using probabilistic tools. To fix this, developers must stop testing the text the agent writes and strictly test the tools it calls. Agent-vcr was designed for this purpose. Much like an HTTP cassette recorder saves network calls for testing, agent-vcr intercepts and records LLM tool invocations. The setup starts by running your agent once using a live model, with agent-vcr set to record mode. Under the hood as the agent runs, it logs tool names, validates argument shapes, and maps the exact routing sequence. By capturing this data, an unpredictable generative session is locked into a fixed, verifiable file called a golden trace. Adopting this deterministic validation does not require tearing down existing LLM architectures. The system relies on adapters that plug directly into major frameworks. Whether building with OpenAI, Anthropic, Vercel AI, or LangChain, agent-vcr snaps into the pipeline. Since traces are saved as plain JSON, the behavior exists independently of intent. Any language parsing JSON can verify the agent's logic. Robust AI testing is no longer about reinventing the test harness, but simply capturing the correct state machine. Once that golden trace is recorded, developers commit it into version control alongside the application code. This acts as an automated tripwire. Opening a new pull request forces the system to replay the trace deterministically against the new code. This replay happens without hitting a live provider API, eliminating the cost of running large models for every automated test. It also removes the bottleneck of slow network requests and flaky generative responses from the continuous integration pipeline. Two validation modes exist. Exact matching ensures one-to-one sequences for rigid workflows, like financial transfers. Subsequence matching allows intermediate steps for flexible pipelines. If tool order drifts or arguments mutate during a check, the system catches it instantly. The build fails on the spot. Agent-vcr ensures that if an agent's tools move incorrectly, the code never reaches production. Prompt engineering becomes safe because the mechanics are verified before they ship.